Hello, everyone. We're going to get started here. I'm excited to introduce Alex Miller, our VP of Research and Curriculum today. She will be talking about STEAM education in early childhood, some strategies and activities for teachers and families. If you have any questions, please put them in the Q&A and we'll try to answer them as best as possible. So Alex, go ahead and take it away.
Awesome. Thank you so much. Appreciate the intro, Jamie. Hi, everybody. It's great to have lots of folks on today. It looks like we've been climbing up slowly with our participant numbers. So glad to see we've got a lot of folks in already. I'm sure more will be coming in as we progress. Yep, feel free to say hi in the chat. I see some folks are already here. Feel free to introduce yourself, where you're calling in from. I really appreciate seeing where everybody's trickling in from. So I'm going to get started though, because we have a lot to cover. I may ask you guys a few questions to participate here in the chat. So if you're feeling up to it, definitely do it. If not, all good. If you do have questions while I'm going, as Jamie mentioned, feel free to plop them in the chat. I may find time and opportunities to answer questions throughout, or we may wait to the end. Awesome. So yes, we are here today to talk about STEAM education in early childhood, different strategies and activities for families and educators. My background is first and foremost a former early childhood educator myself. I taught in preschools in New York and in California. I'm based in California now. For those who are calling in, I see New York, Louisiana, Philadelphia, Texas, Canada, even. Great to see everybody's calling in from all over. And since my teaching days, I've also worked at other ed tech companies and publishing providers, but core to what I do is to ensure that everything we at Hatch build and design has the educator and the child in mind. So today, our agenda is talking about the importance of STEAM education, first and foremost. That's why we're all here. The next thing we'll be talking about are research-based practices and resources for integrating STEM into our early childhood settings, and then common challenges and misconceptions about teaching STEAM to young children and practical tips for overcoming those. And then lastly, we'll talk about some real activities, real practical things we can do to promote inquiry, problem solving, collaboration, and communication, which are all connected to our STEAM skills. So with that, let's jump right in. So STEAM learning experience have many benefits for our young children and their learning. STEAM activities can help children experience engaging and fun learning experiences. We all know how fun it is for children to go outside and explore and see nature, connect to the world around them. We know how important it is as well for children to see and touch and feel the world that they live in, to better understand it using all of our senses. And then to achieve academic success. There is a lot of research out there, and while this is not an exhaustive list, STEAM activities can really help children develop their cognitive skills, right? They can develop language and communication skills, critical thinking and creative thinking and creativity, reasoning and logic, communication skills as well, problem solving, executive function skills, collaboration, and of course, curiosity and fine and gross motor skills as well. I think I touched on everything on this slide, but as you can see, STEAM is so important for not just developing those science, technology, engineering, art, and math skills, but so much more. Everything is connected. And while you're in the chat, actually, folks want to talk about some things that they've seen, some benefits they've seen of STEAM education, that would be amazing as well. Would love to see what you guys have seen. Additionally, STEAM careers are growing. I don't know how many of you guys are based in the California area, but I love our local news here. And every once in a while on the local news, they do a STEAM feature, and they feature different careers in the California area around different STEAM careers, and highlighting and showcasing what those skills are and what those jobs are to really promote that. So it's clearly something that's happening more and more. In 2021, there were 10 million STEM workers. STEM and STEAM are used interchangeably in some ways. We in early childhood focus on the STEAM because we know how important arts is, but sometimes when you hear it, you'll hear STEM. There's a projected growth rate of 11% by 2031 of these STEM workers, and that growth is 2 times faster than the total for all other occupations, meaning helping children develop these STEAM skills early can really help put them onto a path for success in adulthood in terms of their career potential and their career opportunities. So now at this point, I'm going to jump into some STEAM myths and misconceptions, because I know a lot of folks in early childhood, we do a lot of STEAM without even knowing it sometimes, but when we hear it, it's kind of like, ooh, I don't know, maybe just focusing on the language and literacy and math and those social emotional skills. But here's some things that we can address when it comes to STEAM. So the first myth or misconception is that STEAM activities require fancy and expensive materials. They do not. Right? STEAM activities, children don't need fancy toys or expensive supplies to practice STEAM learning. And we'll talk about some of these specific materials that are already found in homes and in classrooms. And adult interactions are even more important sometimes than kits or different materials. The second myth is inquiry-based education needs no teacher involvement. We know that children, especially in this young age, really need teachers to guide, support, and encourage their learning. And responsive interactions with teachers can really help children go from just using their senses and exploring to actually using that exploration to learn and to process. There you go. The third myth is that engineering is too advanced for preschoolers. I actually did some early coding with my preschoolers when I taught, and so we'll go into some of those skills as well later on, but engineering is not too advanced for our preschoolers. Engineering is problem solving. In many ways, engineering is following directions if you're thinking about coding. It's about wondering, exploring, and creating solutions and trying and failing and repeating. And we all know that's what our youngest learners do every day, all the time. And really that engineering process in preschool is helping children build that persistence and resilience that we know is so important to executive functioning skills. And that research shows that children during their play are engaging in engineering processes every day. Myth number 4. Language and literacy are more important than STEAM. And as you guys saw from before from my previous slide, all domains of learning are important and interconnected. And as we saw, sometimes STEAM practice can help children build their language and literacy skills, right? Book reading, children asking questions and engaging in conversations about these topics can be so valuable, and also in helping expanding their vocabulary. They also explore these concepts by using their language skills to talk about what they've explored and share their experiences. So it's not about receptive language, it can also be about expressive language. And the last myth, technology is just computer and screens, which is the T in STEAM. And the T is actually, and this technology is actually about, like the reality, that children can explore technology using concepts without screens. It's really about the underlying concepts of building and creating and utilizing technology, like potentially, again, like we talked about with the engineering process, coding, computational thinking, which is problem solving. So technology doesn't have to mean computer and screens. It can mean a lot. I hope that was helpful for you all. At this point now, we're going to dig a little bit deeper into each part of the STEAM and learn why each one is important to learning and how, as educators, we can support children in exploring each topic, skill, or area. And so at this point, I want to give you guys an opportunity to type in some of your questions if you have any, or anything into the chat as it relates to some of those myths or misconceptions. Any of those were relatable to you all, feel free to put that in the chat. Or if those were things that you've already known, that's amazing. But definitely want to hear from you guys as we go through. So, STEAM. Let's dig deeper. These are 5 critical areas of learning and exploring: science, technology, engineering, arts, and mathematics. So STEAM learning involves inquiry instruction, and inquiry instruction is really hands-on, active learning experiences that support building skills like critical thinking, which we talked about, problem solving, communication, reflection. And this teacher support and inquiry instruction looks like asking open-ended questions and providing children with opportunities to activate their own curiosity, to ask more questions themselves, not just the educator asking questions to the child, but the child asking questions to the educator where they don't necessarily have the answer. That was one of my favorite parts about teaching preschool, was when a child would come to me with a question that I didn't know the answer to, and we could explore it together and solve problems together. This inspires children to have wondering, thinking, and exploring. And teachers can do things to activate inquiry instruction by asking questions, introducing a problem or an idea, helping children develop the skills of wondering, guessing, and predicting, because those are not all common practices that our youngest learners come into preschool with, and allow children opportunities, again, to independently think through and solve problems. So we're not providing all of the answers or the solutions for them, so that they can have that opportunity to express and activate their curiosity. So just like all early learning experiences, the context in which this learning takes place is so important. And STEAM concepts should be taught, as we plan all of our lessons, right? With direct instruction and integrated throughout our everyday practices. This integration helps teachers focus on the STEAM content and the STEAM process, and that STEAM content helps them understand what to learn, as well as the process of how to learn. So you might recognize the design process as important engineering skill, right? The what to learn, and then think through the best way for children to practice that skill, such as problems. So that's the two components. Yeah. So let's look and start with science, the first one, the S. As experienced early educators, you're all familiar with the science concepts, and many of you have standards and skills related to science that you guys are having to meet throughout the year. So we'll spend our time today walking through the process of science, not specific skills as it relates to science, as well as how teachers can support scientific learning. So the scientific process for young children looks kind of like this, right? First, they're going to observe something, right? They may hear something, taste something, feel something, smell something. We may ask questions for children. What do you notice? What do you see? What do you hear? When children are observing, they're paying attention to and noticing what is happening. And this is a key science skill for scientists, right? We want to be observing as scientists. We observe as educators, right, as well. The next step is making predictions. This is when children make an educated guess about why something happens or what will happen if. I remember I had a child, we were walking to the park and there was a dried up worm on the sidewalk, and they observed it, they noticed it, and they said, why is this worm dried up? And that I said, well, what do you think happened, right? I helped them think and predict about what happened. They said, oh, I think the sun dried up all of its bones. I'll never forget that. I thought it was so like brilliant, right? That they predicted that they know they have bones. What makes something flat? The bones give you structure. So they made an educated guess about why that happened. Then the next thing is experiment. We did not experiment with the worms on the sidewalk, but we did plenty of other experiments. And this is when a child is creating a test to see if the prediction is correct, right? Which happens a lot. It doesn't look like a full-blown scientific experiment in many cases, but what does that look like? What supplies will you need and how will you test your prediction? And then the next step would be interpreting, right? So what happened during that experiment, during that process after you made that prediction? And what happened? What did you observe again based on your experiment? And why do you think that happened? And then the last piece is that they'll share, right? They'll share out what they've learned and what they now know. From that experiment, you're going to find results and have insight to be able to share with your friends, with your educator, with your families at home. And in early childhood, that can look like a lot of things, right? That's part of the language and communication we talked about, orally sharing, as well as writing or drawing results, which we've done a lot as well. And so what can us educators do to support the scientific process, right? We can observe and describe. We can model that for children, right? We can talk about what we see and what we observe as well, using rich vocabulary to build that, those language and communication skills as well. So what did you notice, right? I noticed. What did you smell? What did you see? Was it heavy? Was it soft? Was it lots of rich questions that we can be asking? We can ask more questions, open-ended questions that encourage them to think critically, not just about what they observed, but about what they could predict, right? So what do you think will happen if? Why do you think that happened? How can you investigate this to get more information? And when you ask that, then you can lead into the experiment and finding out what to do next. And then you can ask children to think through that process. So how can you test that? How can you explore or answer that question you had? And then sharing the information and resources, right? About offering books or videos to help children learn more. As far as their ability to interpret what they found out. You can learn more about in this book that we have about worms, right? There's more. Do worms have bones? Let's go find out in this book. And you can make suggestions and offer ideas and advice about other things to try, right? I wonder what would happen if you might want to try this. We do that a lot, oftentimes without even knowing it. When we're thinking about ramps and things with wheels, when we're moving things down, if we make it steeper, if we make it taller, what's going to happen? We do a lot of that experimenting and testing in early childhood as well. So now let's look at a very specific activity that we came up with as an example of a science activity that we can do in the classroom with children without a ton or even really any materials at all. Going back to our myths and misconceptions. So this activity is called Mini Meteorologists, small group is a good size with this. You can also introduce it to your whole class and break into smaller groups to help manage it. But the objective here is to use the scientific process to explore and predict weather patterns. And all you really need are some sort of writing implement, whether it's, pencils, crayons, markers, whatever you use best in your classroom, some sort of paper to write on and to track your observations, and then super helpful to have a calendar as well, which most of us use for our days of the week and things like that. So it should be all stuff that we have in our early childhood classrooms. And what you'll do is first you're going to observe. So every day, you're going to ask children to think about what they observe, seeing, or happening. What do you notice about the weather? Is it sunny outside? Is it cloudy outside? Has the weather changed? Why does the weather change? What do we know about seasons and weather? And then we can predict. We can ask children to guess what will happen or why something will happen, right? What do we think the weather will be like tomorrow? Maybe that's a little tricky because even our weather people maybe sometimes don't know what the weather will be like tomorrow. Next week, next month, maybe in a couple of months when the seasons start to change, really allow children to use that scientific process. And then we can experiment, right? This is a simple experiment. They don't have to build anything or do anything. All they have to do is observe and record their observations of the weather during morning meeting or small group over time. Then you can interpret it. So help children analyze or think about their results. They can be thinking about it on a weekly basis, a monthly basis, however you want to think about were your predictions right? Why do you think they were right or wrong? And we can create some sort of chart or graph to interpret that, to represent that, and use that to share the results out with other groups, with the whole class, with other classes, or with families. Again, if you have any questions, feel free to pop them in the Q&A section as well. And so for this activity that I talked about, as I said, there's not a ton that you would need for this, but other ideas for supplies or materials to support the science exploration in your classroom might be science tools like thermometers, magnifying glasses, microscopes, safety goggles, scales, binoculars, rulers, and measuring tape. Tools for exploring like eyedroppers or pipettes or little tweezers. Those are also super helpful for fine motor skill development. They have child safety tweezers, not the sharp ones that we use. Measuring cups, which I'm sure many of us will use for cooking activities as well, which are great for science. Magnets and gears, like I talked about before. And then there are natural materials, right? We know in a lot of early childhood centers, we go on exploration walks, we collect different leaves during the changing seasons. We know that children, when they go on walks, always see something and they want to pick it up and take it. But how do we nurture that in a way that's helping foster science and scientific exploration? We can do that in the collection of rocks and sticks, shells, pine cones, acorns, things that children will see on their walks, whether it's with you as the educator and you can help collect them in a safe way, or with their families. And again, they can bring them in and you can put them in a safe space in your classroom for observation as well. Oftentimes we have our sensory stations. I would keep these natural materials, found materials near the exploration station, and we would move them in and out. We would rotate them through the sensory station as well, so they could explore some of the natural or found materials using, our magnifying glasses, as well as measuring cups and things like that. Then you can have writing and drawing supplies as well to record their observations. My art center was adjacent to my sensory center, so it was super helpful to have that nearby so children could record their observations as well. And then books that support this learning. So I would sometimes bring over specific books as it relates to what we were observing to keep it in the area so they could use it as a reference. Or, depending on how your classroom works, children may go independently knowing that there's a book over there and go and grab it and bring it over to a center as well. So those are all things that likely are things that you already have in your classroom or things that you can invest in as well to help foster that scientific exploration. So now we're moving on to the T, to the technology. When you hear the T in STEM, again, you might think of computers and screens, but there's plenty of other opportunities for technological exploration. And it's true that children can explore technology through the use of apps and games and circuits and robotics kits. But if those tools are not available in your classroom, if you don't want those in your classroom, there are other ways that we can help children explore technology as well. And before we jump into that, there are some underlying concepts of technology that are used to create, that are used to help us create the technical tools. So one of those concepts is higher order thinking. Higher order thinking refers to the skills that we need to solve problems, to transfer knowledge, to adapt and to reflect, which are really important things that we as adults do every day in our life and in our jobs, and to navigate the world around us. So even if you don't work in technology, you use these important skills every day to be successful. And so we want the children that we work with to develop these skills. And so using technological exploration is a great way to help them do that. So that's predicting and analyzing, which we talked about before, also sequencing, sorting, rule making, patterning. All of these different squares here are different skills that make up higher order thinking. So another underlying concept in technology is the idea of computational thinking, which is the creative ways of thinking that allows people to solve problems, identify issues, think critically, and then develop step-by-step instructions that allow other people or computers, if you're talking about coding, that they can follow. So research actually has shown us that these types of experience are really critical to helping in early childhood to develop other academic skills that support school readiness. And so while computational thinking may seem advanced or a complicated field, it's really just sequencing and patterning and executing on those. And so there's 3 basic steps, which are listed here. Algorithmic thinking, which is creating ordered steps or sequencing, nothing complex. Algorithmic thinking sounds complex, but all it is sequencing to solve a problem in a way that can be used by others. That's the algorithm. So if you think about it, when children get in line and we get in an order, during transition times, when we move from the rug to our desks, to our stand up in our lines to go walk outside, there's a series and a sequence of events that we need to go through so that we can go and walk in a straight line and execute on that. That is a way to interpret algorithmic thinking that's applicable to early childhood. Then there's the debugging process, which is the process of fixing or improving solutions. So when you try to solve a problem and your chosen solution doesn't work, you have to debug, or you have to reflect, and you have to try and figure out what to change. And children naturally engage in this process all the time. For example, building a tower in the block area, when it falls over, may think through, how do I build this sturdier? Maybe I use a bigger block at the bottom, right? Or I do multiple blocks at the bottom. Then there's the design process, which is making something by creating, testing, and improving, which again, the same example could apply here. Also, in thinking about stringing beads together, it may keep falling apart. They may want to wear it and then it keeps breaking. And so we need to find creative solutions like finding tape instead of just tying it to make it stronger so it doesn't fall apart. So that's the design process. And teachers can help children practice these skills by being an active partner in their exploration, by providing fun activities for sequencing. It could be an activity that's related to how we get dressed in the morning too. That's another way that we put on the order of events, right? We don't put on our shoes before we put on our pants. We put on our pants first. Exploring patterns and finding and fixing those mistakes in our patterns, and making big problems more manageable by breaking them down, fixing and improving, creating and testing, which again are super helpful for children to think about developing those executive functioning skills of how do we take something that feels so crazy and stressful and break it down into something more manageable. So with that, what can we do? How can we engage children in this process? So coding is the process of creating instructions that tell a computer, website, or other interface, or even person in many cases, what to do. So here's an activity that you can do with potentially some materials that you have. This is called coded bracelets. Again, you should probably do this one in a small group, less likely in a large group. Again, you can introduce it, model it in your whole class. This is exploring the basic principles of coding and sequencing, using beads of a variety of colors. Maybe you don't want to use small beads. If you're working with threes, you can use bigger beads, or maybe you have shells that you use or that you found in your nature walks that you can use, string, scissors, paper and markers. And the first thing that you're going to do is you're going to prepare for this activity by creating a coding guide, right? By writing each letter of the alphabet on a piece of paper and assigning each letter a different code. So A may equal 1 white bead, and B may equal 3 yellow beads, etc. And then you can create the sequence, and then you'll model this, encourage children to, maybe they're going to spell their name, right? That's a great skill that we want children to learn in early childhood. So my name is Alexandra, but let's go with Alex for that. So let's say A is a white bead, L is 2 blue beads, E is a yellow bead, and X is 4 red beads. So children have to follow that pattern to match and sequence in spelling their name. And then we'll support children in their small groups. So allow them to explore the materials, offer support when needed. If their name is long, if it feels so complicated, we can find ways to make it easier for them by picking a word maybe for them that's more appropriate for them to do for this activity. And then reflect, ask children to think about what other words or messages they might want to spell out. Maybe they want to do mom or dad or grandma or something fun like that. Or maybe they want to spell out their favorite color or their favorite animal, and lots of other opportunities there as well. And so for supplies that we, or materials that we can use to help support this technology exploration, again, other toys or materials like blocks, balls, art supplies, anything that can help children practice cause and effect and trial and error. Also supplies for patterning and sequencing, like we mentioned, blocks, beads, different counters, pom-poms, the little bears or sequence cards, open-ended materials for design and creation, like cardboard boxes or scissors, tape, opportunities to plan and sequence these events and actions and during small group as well. And then books that support this technology learning as well. So we are up to the E in STEAM, engineering. Engineering is the process used to solve problems by designing, building, and testing things. So this process, while both science and engineering are part of STEAM, it's important to differentiate between the scientific process and the engineering process. So the purpose of the scientific process is to answer questions through investigation, while engineering process is to solve a problem through design. So slightly nuanced, but important to for our conversations here today. And in early childhood, a lot of times those look intertwined, right? So here's the engineering process for children. Here's how it flows out, similar to as we did with the scientific process. So for children, it's about finding a problem. So identifying something that doesn't work well or like it should, right? Slightly different than the example of the worm on the ground. So maybe the problem is the zipper on their pants isn't going up all the way, or the chair at the desk is a little wobbly, right? And they're having a hard time sitting still because the chair is wobbly. Why is the problem? What is the problem, right? And what is the need to solve, right? The chair is wobbly. I can't sit still, Miss Alex. Why is this important? It's important for children to sit still when they're eating. It can be dangerous. We want to make sure that they're sitting safely while they're eating, while they're listening. What have other people done to solve this problem? Have you ever seen this before? Has this happened to you at a restaurant or at home? The next step is imagining and planning. So thinking through ways to potentially solve the problem through design, thinking of possible solutions. Maybe you sketch it out, draw it out, build a model. And then of those options, you get to choose your plan and identify the materials that you need and find them. And then after that would be creating. So building a model or prototype of your design based on the plans or the sketches, getting feedback and testing, right? So you may say, oh, I remember we were at the restaurant and the table was wobbly and they put a napkin under it, or they put the menu under it. Well, we don't have a menu in our house. We don't have a thick napkin like a restaurant. What could we use, right? Oh, we could fold the paper. We could use a book. I don't want to use my book. So let's use pieces of paper. So we get some paper and you fold it up, or maybe it's the top of a cardboard box, test it out. Then you improve, right? So maybe the piece of paper was too thin and it still was too wobbly. So we tested it, we iterate, we get a piece of cardboard and that fits just right, right? And so after testing and thinking critically about how to improve your design, so maybe the cardboard piece is too big and it's getting in the way of others, we can probably cut that piece into smaller pieces, right? Then you can reflect and redesign based on what you've learned. So how can we as educators support this engineering process, right? We can observe and describe, talk about what you see and observe. We can ask open-ended questions that encourage children to think critically. Again, these sound very similar to what we were talking about before when we were talking about science exploration. So those are similar ways that you as the educator can engage, although the outcome is very different for the child process. Then find out what's next. So are you planning to add more paper? Are you planning to cut the paper up? How are we going to think through that process with children? Then again, sharing information and resources that we know could be helpful, like books or videos to help them learn more. And then we can make suggestions. So offer ideas or advice about things to try or think, right? I might prime children to think, have you ever been at a restaurant and had a wobbly table? That could be a helpful way to get children to think through that process. And so here's an activity that you can do. That's another simple example of an engineering activity in your classroom. This is actually an activity that we did in one of my classrooms. One of my students' parents was an architect, and they use the engineering process in architecture a lot, like we talked about the building of the blocks. And they brought in they helped us build marshmallow structures. So again, this was done in small groups. And the objective here was to use the engineering process to explore structure building. The materials were paper, crayons, or markers, the jumbo marshmallows, and some plastic straws. We used tongue depressors for when we did it instead of plastic straws. So you can be creative here. And the first thing you do is tell children that you have these marshmallows and these straws or the tongue depressors, and you need to build a structure with these materials. You may want to read a book as well before about it. Rosie Architect, I'm getting the name of the book wrong, is a good one. Or you could maybe even do the Three Little Pigs and talk about the different structures that they built. Then in imagining and planning, you can ask children to think about and brainstorm how they can build a structure that doesn't fall, maybe remembering their time when they built a structure with blocks and kind of prime them to think about that. Maybe before you ask children to sketch or draw the design of the structure they may want to build, right? That allows them to iterate there before they use all the materials up. Then it's time to create. So allowing them to build and experiment, and then share out their observations and reflections, and then maybe give them the opportunity to improve and to iterate. So encouraging them to keep improving in that process. And so what are some materials and supplies that you can have in your classroom to help support this engineering exploration? Blocks of varying sizes and shapes and materials, building materials, cardboard, paper plates, popsicle sticks, etc. Again, the loose parts that you've found from nature, as well as other loose parts like cotton balls, etc. Classroom toys, like different cars or art supplies or other pretend play objects you can use. And then books, again, that support engineering learning. And now we're up to the A. I'm going to take a quick sip of water because I've been talking a lot, and let you guys have an opportunity. If you have anything that you want to share in the chat about activities you've done, that would be amazing to share. Or if you have any questions, feel free to pop them in the chat.
And Alex, I wanted to launch a quick poll just to get a pulse on everything. So everyone, if you have a chance, please go ahead and fill out this question I just posted.
Awesome. Is it okay if I move it?
I'm going to go ahead and end it here if everyone's done getting a few more answers in there.
All
I'll
right.
give it until 1 minute.
Sounds good.
All right. Thank you, everyone.
Thanks, Jamie. Great. All right. Up to the A in STEAM. The A is arts, which may kind of feel like a little bit of an odd one out. But if you think about some of the themes that we've talked about so far as it relates to exploring and testing and improving, as well as thinking critically, and also around design, the art part that children are practicing all those skills, they're really exploring art as well. So how can teachers support the art experience and the art process, right? They can plan art experiences that are expressive, allow children to express their feelings, thoughts, and ideas. Art experiences that are exploratory, giving them the freedom to create and explore different materials. They can give some self-directed art experiences as well, which is the freedom to, manipulate and explore different materials and methods, make the process focused. So focus on the exploration and not the end result. They can make it fun, low pressure, engaging. That's really important for the art process as well. And when children are engaging and thinking about art, you can talk about different ideas. So what were children thinking when they made the choices they made, right? Tell me, what are you thinking? What made you decide to draw this? Why did you choose the markers over the crayons? Why did you choose the red color instead of the brown color? About the process. So how they made their art, right? It may be afterwards. So how did you make this? What techniques did you use? Did you hold the marker like this and make dots, or did you make long strokes with your hand like this? Do you have a plan, or did you figure it out as you went, right? Did you think about this before? Do you have any problems while you're making it? Did you run out of, did you run out of space? That happened all the time. They ran out of space, ran out of room. So they got another piece of paper and taped it on, or went around the back. How did you solve that problem, right? What materials were used? Did you use tape with extra paper? Tell me about how that worked. What would you have done differently next time? You can engage in knowledge. So talking to children about what they know about their artwork, right? And helping them build their vocabulary as well. So I see lots of different shapes and colors and textures and lines. Tell me about those shapes. I noticed some colors are dark and some are lighter. Tell me about that. Some are thin, some are thick, some are wavy, some are swirly, some are straight, right? You can use lots of different rich vocabulary as you're asking children about their work as well and what they know about those art concepts. And then reflect, right? How do they feel about the art? What was your favorite part? Is there anything that you would do differently? What would you add? What would you subtract? And if you made this again, what would you change? How did it make you feel now? How does it make you feel now? How did it feel during the process? And then talk about the future. So what will they do next? What do you think you will make next? What kind of art do you want to try and learn to do after? And so let's talk about an art activity. So here's an example of a simple art activity, again, with things that you may have easily accessible to you. Again, small groups. This is the objective here, is to allow children to explore, experiment, and discover through art. Materials are coffee filters, markers, a spray bottle, water, and the chenille stems. During the initial process, right, we're thinking. So asking children how they might explore and create using these materials that we provided them. Then during the creation process, allow them to explore the materials any way they want at first. Allow them to use additional materials if desired, and then sharing your observations and reflections. And then reflect, encourage children to use this process and reflect on their art, what materials they used and what was the outcome of that. And if you want, you can create a model for them ahead of time if you want it to be more focused and directed and less explorative in nature, as we talked about before, right? This could be an opportunity for expressive and exploratory, or it could be an opportunity for self-directed and process focused. And you can use different books and things as well to encourage their creation. And then what kind of supplies, right? I think most of us have in our early childhood classrooms, lots of supplies and materials to support exploration like this. So things may vary, like different writing implements like pencils, markers, crayons. Maybe you have paints, maybe you use oil pastels, maybe you have clay. Also paper and other ways of creating, like cardboard, wrapping paper, tissue paper, poster board, canvas paper. You may have other loose parts that you can glue or stick on, like pom-poms, pipe cleaners, fabric, buttons, ribbons. You could even use sponges. That's also fun for sponge art as well. And then you can use different tools like staplers, tape, glue, hole punch, scissors. And also, as I mentioned before, books that support art learning. And now, last but not least, we are up to the M in STEAM, which is mathematics. Math is measuring, sorting, building, pattern making, making comparisons, as well as describing the environment, counting shapes. There's so many ways that we can incorporate math learning into everyday moments, as well as into a lot of the other pieces that we talked about, right? You can incorporate math into science, incorporate math into technology, into engineering, and into art, just like we can do art into others. So how, as teachers, can we support math experiences? So first and foremost, we can build on what children already know, right? Using the progress monitoring and our assessment data, we can help plan math activities that build on what children already know to allow us to differentiate and scaffold our instruction to create purposeful, targeted, and meaningful math instruction that matches children's knowledge. This helps children be appropriately challenged and supported in their zone of proximal development. We can then teach children to view and describe the world mathematically, right? Math isn't just a way to count or to sort, but math is a way that we can approach the world. So we can incorporate math vocabulary into our instruction and our daily interactions. So we can ask open-ended questions to help children build that math vocabulary and explain what they've learned. You can also encourage children to talk about math in everyday situations, like on the playground or getting ready or being in the gym. Lots of different counting opportunities out there in the real world. And then you can also provide dedicated math instruction and integrate it throughout the day. So planned structured math activities can strengthen math skills for children by also connecting math skills to everyday situations and routines. Those math concepts become more meaningful, just like the science concepts become more meaningful when they can touch and feel it as well. And so children can practice those skills then in a meaningful way. So try thinking through your lesson plans and looking for ways or places to incorporate math concepts into other activities. So you can think about that in terms of like lining up to go outside, right? Maybe you're making patterns, maybe you're counting as you go up, and then you can do that while you're lining up to go outside or setting up for lunch, etc. So what's an activity we can do? This one is called Muffin-Tin math, again in small groups. The objective here is to practice number recognition, counting, and cardinality. The materials we need are metal muffin or cupcake tins with the muffin liners, markers, and pom-poms or some other materials that you can put inside. So in preparation, you're going to write a numeral on each cupcake liner and place it in the muffin tin in a random order. Could be sequential, it could be random. Modeling is the next step. So encouraging the children to fill one section of each muffin tin with the number of pom-poms or whatever material you're using that's written on the cupcake liner to match the numeral. You can model this first depending on where children are in that small group. Maybe they don't need modeling for this activity, maybe they do. And then you'll be supporting them. So first allowing children to explore the materials and play freely, and then kind of giving some self-direction and guidance and sharing their observations and reflections. And then you can reflect. So go through each section one by one, count the number of pom-poms you see matching the numeral. And if they don't match, maybe talk about how, why, what did they do? Why did they put 3 in here when it said 2? You never know why they may have done what they've done. And then again, you can iterate and repeat, add new numbers, move stuff around, and help build those counting, recognition, and cardinality skills. So what are some supplies or materials to support math exploration? Again, manipulatives, we've talked about a lot of these things we're going to see are repetitive to other materials as well. So counting, patterning, sorting buttons, counting bears, I mentioned those as well before, die, number cards. You can also have math activities like pattern boards, puzzles, sequencing sets. Those are all great to help build math skills as well. And other games that support math concepts, money, and time and calendar supplies are also really helpful to help build those early math skills. cash registers, as well as clocks, pocket calendars, and other time-telling activities, as well as books that support math. So now we're going to talk about STEAM practices and resources. So there are 3 types of STEAM instruction that can be very useful to teachers to implement in their classroom. That's child-centered projects, that's problems to be solved, and that's play-led experiences. We mostly in the activities we've talked about have been, child-centered projects that are educator guided throughout. And so let's talk about some of these in more detail, each of these 3. So STEAM projects that are child-centered are built on children's interests and observations. So in thinking about my classroom experience, so here's an example before we go into that one. This one is around the child's interest. Maybe they saw birds on the playground, and maybe a child asked, what do the birds on the playground like to eat? That's their question. That's their idea. They brought it to the table. Now we're going to explore that so we can help identify different ways. So we can provide different food to birds. We could set up a little bird feeder, and then we can observe and collect data about what they ate more of, right? Did they eat more of the seeds? Did they eat more of the fruit? Whatever it may be. And then we can reflect and connect. So what did we learn about what birds like to eat? Or we can try more, we can iterate, all of that. So for example, in my class, one year we had a lot of children developing really bad colds. And so children wanted to explore what the cold virus was. And we went really deep into books. We got the microscope, we did the whole thing, and we looked into versus viruses and versus germs. And we did a whole deep exploration about that. It was really, really interesting. We used it around the lens of the 5 senses and how sometimes when you have a cold, you have a harder time smelling things, tasting things when you have a cold as well. And that all stemmed from what was happening around children, right? We didn't have a bird feeder or, access to that many birds because we were in Brooklyn. And so we didn't see that as much, but we did get colds a lot. So that was our child-centered project around scientific inquiry. The other one is around children's problems that need to be solved, right? What we talked about before related to, the chair situation. So STEAM problems focus on issues that exist in the child's world, again, making it meaningful and connecting it to them. So what is the problem in this situation? Children keep knocking down creations in the block area on their way to get some water. So what can we do? So the next is we think. So what do we need to know? Children explore why the problem is happening and think of ways to solve it. Maybe it's happening because people don't know. So what should we do? We can put up a sign to encourage children to walk carefully or walk around, and then we can test the plan. So we create the sign, we put it in there and see how many times did it get knocked over? Did it get knocked over more, the same, or less? And then we collect that data and then we reflect and connect. So did it work? So the children reflect and determine that the solution did or didn't solve the problem. If it didn't, they'll try again, right? So children can do that. That's a great way to help them solve problems in a way that's meaningful to them and meaningful to your community and your classroom, and help navigate some maybe classroom management issues you're having and avoid the water from getting knocked over. And then there's the STEAM play, right? That's play-led experiences. These help build on ideas and observations that may naturally arise through children's play. So just like the bird observation, children may notice that when they play in sprinklers on hot days, the puddles disappear quickly. And so they might wonder why that is, and they may leave the water on to see how long it takes to evaporate, while also tracking the temperature outside. So what they may play is playing in the sprinkler on the hot day. What they may want to do is notice, they notice, this is the idea, that the puddles disappear quickly. And we may ask them, why do we think that's happening? And they may say, oh, because it's sunny out, the sun is out, that's why I'm hot, and it evaporates. And so what we'll then do is we'll explore. So the teacher can help children explore this idea with scaffolds and support. So they can place water outside every day and measure the time it takes to evaporate or disappear. And then children will also measure the temperature every day. And over time, we can make a chart showing how the temperature impacts evaporation. And we can share, reflect, and connect on that. So, in sum, this is what we've covered: the importance of STEAM education, different practices and resources that we can use, some of the research behind and myths and misconceptions, different activities that we can do to promote all of these different specific skills, as well as integrated different learning opportunities. So with that, I will leave some time in the last 4 minutes for folks to pop in any questions they may have. And if not, I also have some resources here and references. We will be sending out this recording, as mentioned. Oh, I see a question in the chat. Does Hatch offer a STEAM-based curriculum? So in terms of a STEAM-based curriculum, what we do offer is in our Ignite independent child-led app experience, we have science and technology experiences that help children build those skills. It's not a focused STEAM curriculum. However, we do offer lots of opportunities for children to help build those skills and explore those things through the Ignite platform. This is a great question. Thank you. Additionally, actually, in addition to that, with Ignite and with our other product Ignite table as well, we have Insights, which is our educator data dashboard hub. And there you can also find extension offline activities called curricular experiences. And a lot of those skills offer tons of opportunities for science exploration, technology exploration, engineering practice, art, and mathematics as well. And then, yes, in terms of math and art, we also have in Ignite a ton of opportunities to explore those skills as well.